Alright, so this next part we want to talk about inverse functions. But before we can talk about inverse functions, we have to know if a function is one-to-one. For a function to be one-to-one, that means for each x value or input, it can correspond to only one y value, and for each y value, it can correspond to only one x value. So we already had half of this before for it to be a function, right? So each input can only have one output. That's what makes something a function. But now we're adding this second part that says for each output there can only be one input. So before this meant that we couldn't have any repeats in the x values, right? So we couldn't have 2 go to 1 and 2 go to 4. But now this second part means we can't have any repeats in the y values, right, for distinct values. So if I wrote 2, 1, 2, 1, that's the same point. Those are not distinct. But if I had 2, 1, and 3, 1, I have a repeat in the y's, then this would not be considered a one-to-one function. So one-to-one, one input for one output for one input. So this first problem says determine whether each function described is one-to-one. So function f has 7, 3, negative 1, 1, 5, 0, and 4, negative 2. So as far as the x values I see, or the inputs, the domain, I see 7, negative 1, 5, and 4. So those are all distinct values. Then I look at the outputs, 3, 1, 0, negative 2, also known as the range. Those are also distinct. So yes, this is one-to-one. Go ahead and think about part B. Okay, so function g here. What did you decide? Is it one-to-one? Negative 3, 2, 6, 3, 2, 14, and negative 6, 2. For the domain, I have negative 3, 6, 2, and negative 6. All distinct, making it a function. And then 2, 3, negative 14, 2 for the range. So here I have two distinct inputs, meaning negative 3 goes to 2 and negative 6 goes to 2, but the same output. So that output has two different inputs that correspond to it. This is not one-to-one. It is a function, but it's not one-to-one. All right, let's look at some graphs. So before, when we talked about graphs, we wanted to determine if something was a function by using the vertical line test. So the vertical line checks to make sure that there's only one input for each output. Well, now we're going to add the second part of this test, a horizontal line test, and that's going to determine if each output has only one input. So it has to pass a vertical line test and a horizontal line test to be one-to-one. So we check this. First graph, graph A. Right away, I'm seeing, boom, vertical line test. This is not a function, so it can't be one-to-one. B here. This is a vertical line. It's touching that vertical line infinitely many times. And the same vertical line. Again, not a function. And definitely not one-to-one. Alright, C here. C, I'm looking at vertical lines. The only place that's kind of iffy is, vertical lines go this way. I don't see any vertical lines where it's going to hit more than one point. Looking at horizontal lines, the only one that's kind of iffy is here. But it's not. It's only going to hit it at one point going through that axis. This is a curve that's getting closer and closer and closer, but it's not ever horizontal. Same thing here. It's a curve. It's not ever completely horizontal. So this passes both the vertical and horizontal line tests. So yes, this is 1-to-1. Why don't you try D, E, and F using the vertical and horizontal line test? Alright, this next one. We check the vertical line test. If I slice through this anywhere on the line, it's only going to touch it one time with the vertical line. So it's a function. But when I do the horizontal line test, it is a horizontal line. It's touching a horizontal line in infinitely many points. It's not 1-to-1. It is a function. It's not 1-to-1. Looking at part E, we do a vertical line test. And even though this is just a collection of points, it's only touching a vertical line once at any given vertical line. We do a horizontal line test. And I see here, if I draw a horizontal line, I'm touching two values. So it's not 1-to-1. On part F here, I do vertical lines, slicing through my graph, and I'm only touching one point at any given time. Then I do my horizontal line test. I slice my graph horizontally, and I see I'm only touching one point at a time with each horizontal line. So it passed both the vertical and horizontal line tests. This is 1-to-1. So for a function to have an inverse, it must first be 1-to-1, and that's why we care whether or not a function is 1-to-1. We can't find a function's inverse if it's not 1-to-1.